All right, so today we're diving into what might be one of the biggest shifts in how we think about artificial intelligence. We're talking about an idea that could finally give AI the one thing it's been missing, just basic, common sense about how the world actually works. The concept is called Jepa, and honestly, it might just be the key to unlocking that next level of machine intelligence.
And this is the central question, isn't it? It's such a weird paradox. We've got these AI systems that can write complex code, they can pass medical licensing exams, but they have zero intuition about the physical world. They completely lack the kind of common sense that a toddler picks up just by, watching stuff happen. And that is the exact problem this new wave of AI research is trying to fix.
And that pretty provocative statement comes from one of the godfathers of deep learning himself, Yann Lecun. He's basically arguing that the large language models, the LLMs that are dominating the conversation right now, are fundamentally a dead end. To get to true human-level intelligence, he believes we need a totally different playbook.
So, let's really break this down. We're in this kind of strange moment with AI, this mix of incredible brilliance and, well, total blindness. The generative AI models we use today can do some amazing things, for sure, but they operate with this fundamental disconnect from reality. So in this first part, we're going to dig into what those limitations actually are and why they matter so much. Okay, so these are the big ones that people like Yann Lecun are pointing to. These models have no real, grounded understanding of reality, which is why we get those bizarre errors we call hallucinations. They don't have a persistent memory, and they can't really plan ahead. When you get right down to it, they're just predicting the next word in a sentence. They're not reasoning about the world. And that's why researchers are convinced we need a whole new architecture. And this brings us to Lecun's alternative vision. It's a pretty radical idea. Instead of just feeding an AI trillions of words scraped from the internet, what if we taught it the way animals and human babies learn? By just watching the world and slowly piecing together its fundamental rules. The whole goal here is to build an AI that develops its own internal world model. And this isn't about memorizing a bunch of facts from Wikipedia. It's about intuitively understanding things like cause and effect, basic physics, the fact that objects don't just disappear when you're not looking at them. The AI learns to predict what's going to happen next, not because it read it in a book, but because it's seen it unfold a million times. And this really gets to the heart of two totally different philosophies. On one side, you've got generative AI, like our current LLMs, and they are obsessed with tiny details. Their whole job is to predict the exact next pixel in an image or the exact next word. But on the other side, you've got this new approach. It's called the Joint Embedding Predictive Architecture, or Jepa for short. And as the name suggests, it's about predicting something much more abstract, the big picture idea of what happens next.
So what on earth is an abstract representation? Well, think of it as just the essence of an idea. It's a way for the AI to grab the most important information while ignoring all the noisy, unpredictable details. It's about learning the rules of the game, not memorizing every single play. And this quote just nails it. It's the perfect way to understand this. A Jepa model doesn't waste its brain power trying to predict the make and model of every single car it sees in a video of a parking lot. Instead, it learns the much more fundamental, abstract rule. This is a parking lot, and cars, well, they belong in parking lots. It's just a much smarter, more efficient way to learn about the world. Okay, so this whole idea sounds amazing, right? A real game changer. But there was a huge problem. For years, researchers knew this predictive approach was the way to go, but whenever they tried to build it, the models kept failing in this really specific and super frustrating way. The problem was called representational collapse. Basically, the model would find a lazy shortcut. To make its job of predicting the future super easy, it would just give every single thing it saw the exact same generic label, or embedding. So its predictions were always correct, but the model learned absolutely nothing useful about the world. It was a complete dead end. This is where things get really cool. Yann Lecun and his colleague Randall Balistriero came back with this groundbreaking paper. They basically rethought JEPA from the ground up, and they provided the missing piece of the puzzle, the theory that finally solved that collapse problem. They called it Jepa, and it completely changed the game. And the solution was actually beautifully simple. It all boiled down to two core rules, or axioms. First, the model still has to do its main job, predict that abstract idea of the future. But second, and this is the absolute key, it has to force all of the concepts it learns to fit into a specific, ideal mathematical shape. So what is that ideal shape? It's called an isotropic Gaussian distribution. I know that's a mouthful, but the idea behind it is actually super intuitive. Just imagine all the different concepts the AI learns as little points of data in space. Instead of letting them all clump together into one lazy point, this rule forces them to spread out evenly, like a perfect sphere or a big symmetrical cloud. That one simple constraint prevents the model from collapsing and makes the whole training process stable and effective.
All right, so a new theory is great and all, but what's the payoff? What can this thing actually do? Well, this is where the story gets really exciting. With that theoretical problem fixed, progress just exploded, leading to AI systems with abilities we've really never seen before. Let's look at what came next.
And you can just see how quickly things took off once they cracked that problem. So the core Jepa idea was floated back in early 2022. By 2023, we started to see the first image-based models. But the real rocket fuel was that Jepa paper in late 2023, which gave it that stable foundation. And from there, boom, an explosion of progress leading to today's models like Jepa 2, which can actually understand and plan in the real physical world.
And how did it learn to do this? The same way we do, by observing. Jepa 2 was pre-trained on a massive data set, over 1 million hours of public internet videos. It wasn't reading text, it was just watching the world to build its internal model of physics and how things interact.
And the results are just stunning. This model is getting top-tier performance on all the standard visual understanding tests. But way more important than that, it's unlocking brand new abilities. Robots that are powered by Jepa 2 can now plan how to pick up and move objects they have never seen before. And, get this, it does it without any specific training for that task or some complicated reward system. It is thinking before it acts, all based on that world model it learned. Which leaves us with this one final, really important question. The success of Jepa seems to be telling us that the path to truly advanced AI might not be about building ever bigger dictionaries, but about building better, more intuitive models of the world itself. It's a fundamental shift from an AI that can only describe the world to one that might finally actually understand it.